Action potential. Action potential is defined as a series of electrical changes that occur in the membrane potential when it is stimulated. Action potential occur in two phases: depolarization, repolarization. Action potential is defined as a series of electrical changes that occur in the membrane potential when it is stimulated. Action potential occur in two phases: depolarization and repolarization. Depolarization is the initial phase of action potential in which inside of the cell become positive and outside become negative. Inside of the cell become positive and outside become negative. Repolarization is the phase of action potential in which the muscle reverses back to the resting membrane potential. So the polarized state of the muscle is re-established. Properties of action potential. Action potential curve. Action potential curve is the graphical registration of electrical activity that occurs in an excitable tissue. Resting membrane potential in skeletal muscle is minus 90 millivolt and it is recorded as a straight baseline. Number one, latent period. Latent period is the period when no change occur in the electrical potential immediately after applying the stimulus. Latent period is the period when no change occur in the electrical potential immediately after applying the stimulus. It is very short period with duration of 0.5 to 1 millisecond, very short period with duration of 0.5 to 1 millisecond. Depolarization. Depolarization starts after the latent period. The point at which the depolarization increases suddenly is called firing level. The point at which the depolarization increases suddenly is called firing level. From firing level, the curve reaches isoelectric potential, zero potential rapidly, and then shoots up, overshoots beyond the zero potential up to plus 55 millivolts called overshoot. From firing level, the curve reaches the isoelectric potential, zero potential, rapidly and then shoots up beyond the zero potential up to plus 55 millivolts, which is called overshoot. Repolarization. When depolarization is completed, plus 55 millivolts is the depolarization. The repolarization starts initially. The repolarization occurs rapidly and then it becomes slow. Repolarization occurs rapidly and then it becomes slow. Ionic basis of action potential. Voltage gated sodium channels and the voltage gated potassium channels play important role in the development of the action potential. Voltage gated sodium channel and voltage gated potassium channels play important role in the development of action potential. During the onset of depolarization, voltage gated sodium channels open and there is a slow influx of sodium. When depolarization reaches 7 to 10 millivolt, the voltage gated sodium channels start opening at a faster rate. When depolarization reaches 7 to 10 millivolt, the voltage gated sodium channels start opening at faster rate. It is called sodium channel activation. When the firing level is reached, the influx of sodium is very high and it leads to overshoot. Then potassium channels start opening. This leads to a flux of potassium out of the cell, causing repolarization. A flux of more number of potassium producing more negativity inside. It is the cause for hyperpolarization. A flux of more number of potassium producing more negativity inside. It is the cause for hyperpolarization. So this is the isoelectric base. So normal minus millivolts. From here, it reached to depolarized state. Depolarized state, that is my plus 55 millivolts. Getting back, repolarization, and then getting much lower hyperpolarization.